This was the exact same concept. I used to score 59/60 in my secondary school. And I want to teach you the exact secret. If you're writing JAMB, move closer. Let me teach you. Now, series connection and parallel connection. Now, this kind of connection, when we have resistors connected in this pattern, is called series arrangement. And we have resistors connected in this pattern, is called parallel arrangement. Now, the problem with this is that people don't understand why we even call it series. And people don't understand why we even call it parallel arrangement. It is very easy. Let me teach you. If you're writing JAMB physics, you're writing JAMB, move closer. Now, if you have current I that is moving, now such that this current can go with this, it can move here. And after that, it moves again. It also distributes, it also moves here. You understand? So in this kind of arrangement, it's called series arrangement. Series arrangement. That means the current in R1 is also the same thing as the current in what? R2. That's the first thing you have to know. That means for series arrangement, please, if you don't know anything, this is what is important to. For series arrangement, the current is the same. In fact, the current is the same. The current is the same. Okay. Please take note of that. That means I total is equals to what will be distributed to I1. It also distributed what will be distributed to R2. You understand? That means eventually, if this is this, of course, the voltage will differ. Voltage is different. So that means V total is the summation of V1 plus V2 for series arrangement. So if you know this one, this stuff will not even smile with you at all, because you will kill it. You will enjoy it. You will, smash it. Now this one, look at it. Why do we call this one parallel arrangement? This is it. When this current is flowing, it will experience an obstacle here, so that this obstacle will make the current to split, so that you have one going to R1, another current will go to what? This, another current will go to what? This, and that is I1, I2, I3. So actually the concept of this thing is explained better with Kirchhoff's principle, but I will not tell you that now. Just know that Kirchhoff's first law is talking about current. Kirchhoff's second law is talking about what? It's talking about voltage. That's when you get to 100 level, you understand that better. So that means if this guy splits here, one will go here, one will go here, another one will go here, and eventually they will not come again. They will also meet at this point. They will converge and also move as what? I total. What can you tell me from there? That means this is a parallel arrangement. Parallel arrangement. Now, for parallel arrangement, what do you think will happen? The I total will be the summation of I1 plus I2 plus I3. That means for parallel arrangement, the current is different. Yes. Why the voltage is the same. That means V total will be what will be in V1. It will also be equal to what will be in V2. It will be equal to what will be in V3. If you know this, I can bet it with you. You already know half of the problem in current electricity, because this thing will help us. Now, the other thing that you have to also understand is that if they are arranged in series, what is the effective resistance like? What is the formula for effective resistance? In fact, let me tell you, that formula that you used to cram in your textbook, in your new school physics, is from this concept. But I don't want to bore you with that. Your exam is closed. I don't need to be telling you how we derive those formulas, but let me just tell you. That means for series arrangement, what happens? You say R total, or sometimes they call it R effective, is equals to R1 plus R2 up to, even if it is plus Rn. This is for series arrangement. If it is capacitor, what will it be? Will it be? I think I should ask you that question. So this is for what? Series arrangement. Series. Don't forget, this axis is series. Now for parallel arrangement, it will be 1 over R total equals to 1 over R1 plus 1 over R2 up to 1 over R what? Rn. Okay, so this is for parallel arrangement. If it is resistor new, please take note of that. So this is R total for series and R total for what? Parallel. See, this thing is important than anything. This is not what is important to. Is this concept. because there can be a question you don't even need to solve. Let's say I tell you that 20 ampere is the total current in this thing. I will now ask you, what is the current in R1 resistor? What's the current in R2 resistor? Some of you will be cramming. You don't need to cram. So the current in R1 resistor is 20. The current in R2 resistor is also 20. So that was how I got that 59/60 in my secondary school. So there was a question on this concept. I just wrote a statement that since the current in R1, since the connection are in series, and the current in R1 is 2 ampere, hence, I cannot forget, hence the current in R2 is also 2 ampere. That was the only thing they asked us to just know. So it's a concept question. You have to understand these concepts. They are very, very, very important. Please take note of this. So you don't need to be cramming all of this, but I know that this is what you want, but I've given it to you. But please note this, because when I will be teaching you conversion of galvanometer to ammeter and conversion of galvanometer to voltmeter, we need these concepts so that you don't cram stuffs. So you understand. So please take note of this arrangement. If they are in series connection, this is the way it will be. If they are in parallel connection, this is the way it will be. And the concept is that the current will split, because when they get to this point, why the current here is the same. So if, as I said, if the current is different, what do you think the voltage? The voltage is the same. I already explained that. So if you have not joined our class, we started JAMB classes. You can send me a DM wherever you're watching this, either on YouTube or TikTok or anywhere. Send me a DM. If you're writing JAMB, this JAMB exam, send me a DM. Join our class. It's almost like barely 1 month or thereabout your exams. So yeah, so that I can teach you directly, and you will learn everything, all the secrets you need to know to pass your exam. Okay. So let me give you a question. So imagine, I want to calculate the R total, the effective total, if R1 is 2 ohms and R2 is 3 ohms. Now, what this question is, if they are in series. If they are in series, that's the first one. Now, so give me the R total in the comment section. You understand? 2. Let me give you, calculate the R total if they are in parallel. So it's like, what are the values? These are still the values. Okay, just tell me what is R total for series connection and R total for parallel connection. So what I just wanted to do is RT equals to this, then put series. You understand? Then RT equals to this, put parallel. Okay, I think with that you'll be able to get it. Of course, you know that Ohms, that man was the man that was explaining the relationship between what? Between V and what? Current. Abi? Understand? So when we now change this to an equal to sign, we now have that resistance. That's so V equals to what? IR. Okay, please take note of that. So V equals to, I think I already made a video on this. V equals to IR. So if I plot a graph of V against I, what do you think the graph will be? So this is another JAMB question. It will be a straight line graph, because V is directly proportional to what? I, provided they are what? Is a conducting materials. See you in the next class. Bye for now. So answer, if you have not, you see that love button, like it to support me, comment to help others, share to help your friends. Bye.